Hey guys, just thought I'd show you one of my electronic devices that I bought. What this is a Geiger counter. I have poor lighting, so you gotta excuse that and all. And I know y'all may be thinking, why do I have one of these? And the reason why is that I wanted, it's one of the many things I have bought to do personal research and all. And the reason why is that one of the things that I've been interested in looking in is just kind of a field study in background radiation. And I know that a lot of people have this concept that radiation solely comes from nuclear reactors, or so forth, or any source of radioactive minerals. And they would be right that radiation comes from there, but it also comes from other sources as well. For example, um, when you take a flight, you're higher in elevation, and hence you're exposed to certain amounts of cosmic radiation and or so. And if you were to go underground, you're also exposed to radiation. So it's kind of like being in between two sources of radiation, because the higher you are, the more you're exposed to cosmic radiation from space, not just not just from our sun, but from the stars and all sorts of radioactive clouds out there. There's a lot of stuff out there that produces radiation, especially if it's a vacuum and all. But also, the closer you are to the ground, you won't. The less you receive from the radiation that you get from space. But the problem is, you also come in contact more with the ground, and the thing is, the ground contains certain amounts of minerals. One of those minerals being uranium, and and the thing is, the more dirt you get, the more concentration of uranium you get. It may not be that much. It's like negligible. It's probably per millions of parts, a negligible amount of uranium, but it's still there and it still radiates. Now there are a lot of other sources. For example, the food we eat contains contains carbon isotopes, and these isotopes are essentially what archaeologists use to radiocarbon date how old something is. And the reason why this is that when our Earth is it hit with all this solar radiation, it shapes off a lot of particles. And what happens up there is what they call a CNO cycle. This is basically a transmutation of carbon, nitrogen, oxygen, and so forth. And what happens is that a lot of those carbon particles um, eventually find their way down here on Earth. And a lot of the living organisms, whether plant, human beings, animals, they ingest that, and essentially that's how we end up with carbon. It's not just on living things; it's on other stuff as well. And basically, almost every organic every organic chemical you can think of. And what I mean organic is any carbon-based chemical. Well, for the most part, the majority of them. But anyway, there's there's other stuff too. Like for example, bismuth. Bismuth is, you may not know what this that mineral is, but bismuth is what they use in it's what they use in what you call Pepto Bismol. And I know y'all know what Pepto Bismol is. It's what you use for diarrhea when you have stomach ache or so. Well, that is radioactive as well, and it's like the last mineral found in last stable mineral found in the periodic table. It's slight it's for the most part stable because the half life of this mineral is essentially longer than the age of the Earth. So pretty much by that time, that much amount of radiation isn't really that big of a deal. There's other stuff like, for example, americium, which are used in smoke detectors. But for the most part, a lot of the radiation we're exposed to is either from the ground, the air, or even within ourselves. That, which, like I mentioned, carbon 12, or another isotope, which is potassium 40. But anyway, I'm getting a little off track and all. What I wanted to show y'all is this device here. What this is a Geiger counter. I have other ones that are have LCD display and all, but I wanted to use this one more precise for this one because it's a lot more simpler and all. And currently the other ones that I have, I need to repair them and all. But anyway, what this is that it receives. There's a tube here, and it's connected to a circuit board. And what happens is that all the particles that this tube receives, since a lot of whether it's beta, alpha, or gamma radiation, it marks it here. And what happens is that as soon as it receives those particles in the tube, it creates continuity between the circuits since it's separated. And when the circuit completes, what it does, it creates a beep. Now this one's a little bit more complicated because there's, as you see here, there's a little jack here. I know that this one's a little cheap looking, but there's this jack here is basically to record data to a USB. Basically, you connect it here, and you connect it to your computer now, and record all the data now. Now, let me show you what I mean. You see here, it started beeping, and every little beep is a particle entering. The more frequent it is, the more higher levels of radiation is exposed to. Now, let me show y'all something else. What I have here is a banana, and the thing about bananas is that it's just is known to be one of the most radioactive food sources there are. Now, if you get this and you put it close to this Geiger counter, it'll start beeping a lot more frequent than it originally was. Start beeping from the background radiation that there was. But let me show you. What I mean. As you see here, it already started beeping. As you saw, it's started actually a click. It's started clicking a little bit more frequently. The reason why is that inside a banana, there's since it's a known source of potassium 40, a lot of it tends to radiate. Essentially, that's why you're getting these beeps and all. I just wanted to show you. One of my electronic devices and all. Please subscribe and comment and all.